Hello, everybody, and welcome to this webinar on Helix applications and logging. My name is Mark Walters. I've been with BMC for about 25 years now. I worked in support, engineering, and IT. I'm now a member of the SEAL team, where I mainly focus on the Helix on-premises applications. In this session, we're going to be having a look at logging, which of course is an essential component of any software system. Whether you're doing development and just need to understand how an application works, and of course for troubleshooting, it's essential that you're able to see what an application was up to when a problem occurred to help you try and fix it and make sure it doesn't happen again. The agenda for today's session will start with a quick recap and overview of Kubernetes architecture and how that differs from server-based systems. We'll look at the Helix applications themselves and how they implement logging. There are some significant differences between the Helix platform and Helix ITSM, for example, that we need to be aware of. We'll see how the components are installed, how the logs are accessed and viewed, and finally a few configuration and management tips for keeping the system running in your environment. So like I say, we're going to start by having a quick look at how Kubernetes works and how it's different from server-based systems. So typically today you may be running one or more physical or virtual machines with an application on each of them. Each one of those applications will have several components, all of which probably write logs to the local file system. Because the great advantage here is if there's a problem with the application and the application fails or gets restarted, is those logs are retained and can easily be accessed to help you understand what happened. When we move to Kubernetes, those physical or virtual systems are now nodes in a cluster. They run Kubernetes software to help manage and integrate the systems together. And your applications are deployed from container images and run as pods across the cluster. One of the most significant differences, of course, in the Kubernetes world is that those pods are ephemeral. By that, I mean that they will be recreated if they are restarted or if there is a problem. The file system that the pods use is temporary. It's used as long as the pod exists, but any logs, any files that are written to that file system are lost when the pod is restarted. So instead, many Kubernetes applications are rewritten to send their important logging information to the standard out and standard error instead of writing to log files. By doing that, it gives an opportunity for some other third-party component to actually monitor that standard out and be able to collect it and send it off to some logging backend. And there are typically two ways that this can be done, or two most common ways within Kubernetes. The first is by the use of a thing called a daemon set, and this provides the facility to run one pod per node in the cluster, and that pod typically runs some type of log collection agent and has visibility to all of the pod output from the pods that are running on that node. So it can gather them all up and send them off to some type of logging backend. The other approach is what's called a sidecar container. So within your application pods, as well as having your container where the application runs, you have a component, a sidecar, that runs alongside it within the same pod and is able to collect the logs from that particular application and again send them off to some kind of logging backend. The main difference between the two probably is in the area of security. The daemon set approach, the pod that's running the log collection generally has visibility to all of the pods that are running on that node, which of course, if you're, for example, in a shared cluster, if you have different teams running applications on the same Kubernetes system, you may not want to have all of the logs from those different teams all put into the same system for review, because you then have issues perhaps around privacy, security, and segregating access to those logs. The most commonly used or one of the most commonly used logging subsystems that's within Kubernetes is known as EFK, Elasticsearch, Fluent-bit, and Kibana. And those are the three components that comprise the logging solution. Elastic is the log collection, the log storage, indexing, and searching component. So that's where all of the logs actually get sent and reside. Fluent-bit or Fluent-D, two slightly different versions of the same bit of software, is the log collection agent, and that can run as either a daemon set or as a sidecar, depending on how it's been configured, to actually read the logs from the pods and send them off to Elasticsearch. And then you have Kibana, which is the UI, the GUI that allows you to interact with the logs that are stored in the system and search and be able to work with them and find items of interest. In this section, we'll have a look at how the Helix applications do logging. As I said, there are some significant differences between the Helix platform and the Helix ITSM systems. So this is the architecture diagram that you're probably familiar with. You will have seen it in the documentation, and this describes the architecture up to the current versions, which is Helix ITSM 23106 and Helix Platform 23102. We have separate namespaces for the Innovation Suite, the IS applications, and the Helix Platform. And the Helix logging components, the EFK bit, lives at the moment within the Helix platform namespace. In earlier versions, it was in its own namespace, but it has been moved in. There's a change coming up in the upcoming 23202 platform release, where the Helix logging components are temporarily being temporarily unavailable. So this is the upcoming architecture. It's largely the same. The main difference is that the EFK component of Helix logging is no longer generally deployed. One of the issues that we've identified with the Helix logging as BMC has been sort of developing the product, particularly around the security. If you've gone through the different versions that we've released up until this point, if you've installed any of them, you will have probably noticed that there's been a bit of a progression. So we've moved from using the daemon set to Fluent-D running as a daemon set in its own namespace, the Helix logging namespace. We moved to Fluent-bit, which allowed us to tighten up security a little bit and move the EFK, the Helix logging components, into the Helix platform namespace to restrict the logs, the pod output they had access to. In the upcoming 23202 release, they say the Helix logging is not by default generally available. The Elasticsearch and Kibana components will still be able to be deployed for use by Helix ITSM, so that the Fluent-bit sidecars that are used on that side can still send some of their logging output to Helix logging, but the Fluent-bit components won't be deployed. They'll be back in an upcoming version. This is just a brief summary of the differences that we have across the different versions of the Helix platform. I say the Helix platform components have generally been written from the ground up as proper containerized Kubernetes applications. So they don't use local log files. They write their output to stdout, and Fluent-bit or any other log collector can then consume those logs and send them off to some type of logging backend. It's changed across the different versions. The 22201 release was the last one that used the Fluent-D daemon set. We've moved to having Fluent-bit, both I think as part of the Helix logging namespace, and then in 23102 the Helix logging moved into the Helix platform namespace. As I just said, in 23202 the Fluent-bit is absent for the moment. It will be back in a future version. We just need to figure out the best way to do it. One of the one of the effects of moving from a daemon set to a sidecar is that because you're running within the context of the pod rather than at the cluster level, you lose access by default. You lose access to all of the Kubernetes metadata. So interesting things like the pod name, the namespace, some of the metadata associated with that pod isn't accessible from within it. There are ways around it. You can import some of the information as environment variables, for example, but it's taking a little bit of work to get that all figured out. So say the 23.202 release will still have Elasticsearch and Kibana for ITSM use, but not for the Helix logging, because the Fluent-bit piece is not available. ITSM doesn't, the main logging components for ITSM doesn't use EFK. The ITSM applications, the IS server, the mid-tier smart IT, at the moment we're using the container technology to package them for deployment. They haven't been rewritten from the ground up as native containerized applications. So as a result, for example, the IS platform pod runs the server process, a number of plugin servers, the email engine. Depends on the sizing and configuration, but there are many applications still running within that one pod, and they still write their logs to files. For those of you that have worked with the Remedy system as well, you'll be aware that the Remedy server, if you enable the debug file sort of filter SQL and API logging, the amount of logs that are being generated can be very, very large. So much so, in fact, that it would probably overwhelm a Fluent-bit type logging system, or at least it would require significant resources on the logging side to be able to keep up with that volume of logs. So the Helix ITSM, although it can use EFK, its primary logging mechanism is a tool called the support assistant. So this is a separate application, a separate set of pods that are deployed, which give you access to the logs running within the application pods. And it does that again by using a sidecar, in this case, a thing called the F packager or FPAC sidecar, which the support assistant can interact with and use to compress and read the logs from those pods to allow you to download them for local use. I said there is an option to deploy a Fluent-bit sidecar, and that will send selected log lines from a small number of log files off to the Helix Logging Elasticsearch. That may be useful, for example, if you want to do some sort of monitoring. If you can tie a monitoring solution into your Elasticsearch or to the Elasticsearch instance, you could look for critical error messages, which might be useful. But the primary logging tool is going to be the support assistant for Helix ITSM. So how do we actually get the different logging components installed? So for the Helix platform and the BMC Helix logging, it's an option that's enabled in the deployment config file. A simple yes or no as to whether it's installed. A couple of extra options were added in the 22.4 release. So we now have a URL for the Kibana instance. In earlier versions, you had to expose an IP address for a service to be able to access it. We've now got a dedicated URL, and also we added authentication. So there's credentials required to access the Kibana instance. Obviously, the logs can contain sensitive information, so you don't necessarily want everybody having access to those. In the 23.202 platform release, by setting the BMC Helix logging flag to yes, so you will deploy the Elasticsearch and Kibana components for use by ITSM, but you won't get the Fluent-bit section at the moment. So how do you so on the support assistant tool, the installation options there, these are done through the Helix on-prem deployment pipeline in Jenkins. The majority of the options relate to the support assistant tool, and then there's also the option to enable the sidecar, the Fluent-bit sidecar for Helix logging. The support assistant tool option that's the one that controls whether the support assistant tool pods are deployed, and that's the GUI that you will interact with to access the logs. And then if you're going to do that, you also need the support assistant FPAC, that sidecar, and then the role, which is a Kubernetes security mechanism for granting access to the contents of the pods. So the first three checkboxes are relevant to the support assistant tool, and the final one is for the Fluent-bit sidecar for Helix Logging. The other option that needs to be set if you're enabling the Fluent-bit sidecar is you need to give the service name and the namespace name that points to the Elasticsearch instance running in the Helix platform namespace, so that the sidecar knows where to send the logs. So with the logging systems enabled and installed, how do you actually look at the logs? Well, first of all, for the pod standard out logs, you have the traditional or the command line based tools that Kubernetes provides. So you can list the pods in a particular namespace. You can be selective and look for particular applications, for example, or particular labels that those pods have. And once you've got the pod name, you can use the kubectl logs command. And what that will do is simply stream the pod standard out contents to your terminal. So that may be useful for a quick review, or you could pipe it through some other tools such as grep to allow you to do some searching, or you could even save it out to a file name locally so that you can use other tools to review, particularly if they're large logs, to allow you to search through them and find items of interest. Because one of the disadvantages possibly of doing things this way, or one of the things to note, is that you will have to collect the logs from multiple pods, probably, particularly on the Helix platform side, but actually also on ITSM when you have a non-compact deployment. All of those systems are highly available, and we get the high availability through having multiple replicas of the pods. So you'll have several RSSO pods, several platform pods in ITSM, and those pods are load balanced, so you won't necessarily know which one of the pods the event that you're trying to find has happened in. So you'll need to collect the logs from the different pods and work with those to find the information that you need. There are ways to make that a little bit easier. So if you're using one of the Kubernetes orchestrators, Rancher or Tanzu, for example, they will almost certainly have their own mechanisms that allow you to view the pod logs, and they probably will have basic searching, sort of Control F, find a string type searching to allow you to quickly look through them. And there are a number of third-party tools such as OpenLens, for example, is one that I use, that it gives you a GUI to manage a Kubernetes cluster, and again it gives you a fairly easy way, or a quicker way of switching around the different pods and reviewing the logs. If you do have the Helix Logging Kibana installed, this is what it will look like once you're logged in and get to the main page and you configured it for use. You get a timeline view which shows the volume of logs coming in, and then the logging messages are also there, showed below. And there's a searching capability. You can search for strings or much more complex search syntax if you're an expert in this area. The logging timeline, along the top of the screen there, can be useful. So for example, in a system that's running in a steady state, maybe during normal production hours, you have a particular load on the system. You would expect maybe the same volume of logs over time. If you have a problem, it's possible that the number of log entries being produced might suddenly spike. So if a component goes into an error state, it may start generating a lot of logs. So that might be a useful clue to help you zoom in on a problem. If you look at this layout and suddenly notice that there's a peak in the logging output, that might be an indicator that you have a problem. The logs that are sent into the Elasticsearch system and are accessible via Kibana, the Helix Platform logs before 23202 are stored in a set of indices that are called log stash. The Helix ITSM logs sent in by the Fluent-bit sidecar are in Helix indices, so you can toggle between the two. And so you can do fairly simple searches to allow you to look for known error messages. You can see there that we're, as I mentioned earlier, the Kubernetes metadata is missing, which to a certain extent limits the functionality or the usefulness of this type of output at the moment. And that's one of the things that we'll be looking to improve in future versions. The support assistant tool, again, access via a browser. Once you're logged in, you get a view of the namespace where the ITSM IS applications are running, and down the left-hand side there are the pods. If you click on a particular pod, then you get to see the different logs that are available from that pod. Some of the pods have only one set of logs. Some, for example, here, the platform, have multiple log sets available because we have different components still running within the pod. The platform, the actual server itself, and the email engine, they use different logging directories. So you have the option to download either all of the logs from the pod or just the individual log sets. Click on the download link, and the support assistant tool works with the fpackager sidecar. The sidecar actually reads the logs from the pod, zips them up, and offers them off to the support assistant to allow you to download them. The download should be relatively quick, but you need to be aware that obviously if you've enabled debug logging, some of those logs can get very large very quickly, and it will consume resources within the cluster as those logs are zipped up and transferred, and particularly over a slow link, for example, it may take some minutes to download the hundreds of megabytes of files that even may still be that size after compression. The files come down as a TGZ file, a compressed tar file. So you probably find, for example, if you're using Windows, you'll need a different tool. The zip handler that's built into the Windows Explorer, I don't think natively handles TGZ files. So you'll need something like 7-zip or WinZip maybe to be able to work with them. And once they're unpacked, you'll find the individual log files, so you can obviously work with those locally and search them just as you would do with the server-based logs that you download today. Or of course you send them off to BMC support maybe if you're working on a case there. So I say there are a couple of things that need to be set up and configured. The Helix logging, there's a job, a curator job that runs as part of the Helix, either the Helix platform here or Helix logging namespace, depending on which version you're using. And that curator tidies up older indices. So by default, each set of indices, all of the logs from the system are put into an index per day. So every day the index files are rolled over and you get a new index. This curator job, it allows you to set a retention period. You don't want those logs hanging around forever probably, so you can modify the default period before installation, or you can do it after installation by modifying a config map that controls it there. There is an issue with the 23102 curator. That means it doesn't necessarily tidy up all the indices. There's a knowledge base article referenced at the end of the presentation which describes how to set up an Elasticsearch index lifecycle management policy so that you can manage those indices through Elasticsearch and Kibana itself rather than from using the installation configuration. On the ITSM side, there's no additional configuration required for the support assistant. It works out of the box and will give you access to the logs from any pod that's currently running. So there's no retention or maintenance required there. However, if you're using the 23102 version of the Helix platform, there were some changes because of the move of the Helix logging components into the Helix platform namespace. So for example, the name of the service is different. So if you're doing a fresh install, you can set that up correctly out of the box. If you're doing an upgrade, you'll need to go and modify that after installation. You also will need to add the HTTP, the Elasticsearch user credentials to be able to log in, and for the Fluent-bit sidecar to be able to connect and send the logging data to Elastic. And there are also some configuration items for the SSL options that have been enabled, and also for compatibility with the newer version of Elasticsearch that is in use in 23.102. Right, thank you very much. I think that's pretty much all there is to talk about on the logging side at the moment. Over, available for questions.